Another skill that's useful when working with fractions is being able to find the LCM, or least common multiple. There's two ways that we're going to learn how to do it. The first one is just making an organized list. Begin listing the non-zero multiples of each number by skip counting or using multiplication, etc. Continue until you get a number that is on the same on both lists. Make sure that it is the smallest multiple that both numbers have in common. So if we're going to find the LCM, or least common multiple, of 2 and 3, the multiples of 2, right? So that'd be 2, right? 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. We could go out one more. 2 times 8 is what? 16. And the multiples of 3. So we'll take 3 times 1 and we get 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. If we did 3 times 6, what is that? That's 18. But we don't really need to go any farther, because we see we have a 6 in both lists and we have a 12 so far in both lists. But we are looking for the least common multiple, and the least common or smallest multiple is definitely 6. Another way of doing this is called the ladder method. The ladder method involves doing something that makes a ladder. It kind of looks like a ladder. So you're going to put the two numbers inside of the top rung of the ladder, or an L shape, and you're going to divide the smallest prime number that will go into both. So write the quotient beneath, and then repeat. Quotient is just answer of a division problem. And you're going to repeat until you have only prime numbers at the bottom and the side. And the LCM is going to be the product, right? The answer of a multiplication problem of all of the factors along the left and the bottom. So we are just going to do this really quickly together. So we're going to find the least common multiple of 24 and 60. So we have 24 and 60. As you can see, I made the little ladder here, right? The little box. And what number goes into 24 and 60? Well, I know 2 does, because they're both even numbers. So 2. So 2 times what is 24? 2 times 12 is 24. And 2 times 30 is 60. So 2 goes into both of those. So now, does 2 go into 12 and 30? Why, yes, it does. 2 does go into 12 and 30. 2 times 6 is 12. 2 times 15 is 30. Another way of looking at it is 12 divided by 2 is 6. So I put that there. 30 divided by 2 is 15. So 6 and 15, are those prime numbers? They are not prime numbers yet, are they? So what are we going to do? How are we going to get those smaller? What number goes into 6 and 15? Obviously, it's 3. So 6 divided by 3 is 2, and 15 divided by 3 is 5. So if you put a box around that side and a box around that, 2 times 2 times 3 times 2 times 5, that LCM equals 120. So the least common multiple of 24 and 60 is 120. So you'll notice that it's the opposite of the greatest common factor, right? The greatest common factor is going to be smaller, and the least common multiple is going to be larger than the original pair. So now we're going to practice. I've already done this first one. 14 and 21. We want to find the least common multiple of 14 and 21. We know it has to be bigger than 14 or 21. So the first step I did here was I did the list method. 14 times 1 is 14. 14 times 2 is 28. 14 times 3 is 42. 14 times 4 is 56. So then this one, 21 times 1 is 21. 21 times 2 is 42. 21 times 3 is 63. I can stop there though because I already have numbers that are the same. It's 42. That's the smallest number that's in both lists. So that is our least common multiple. So let's use the list method for 5 and 6 as well. So 5. 5 times 1 is 5, right? So it's 5. 10. What's next is 15, 20, 25, 30. I ran out of space. I'll stop. And then 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. So, boom. I'll go ahead and stop there because I have 30 here and 30 here. So that is my least common multiple. So now down here on the left, I have 12 and 18, and I used the ladder method. So I wrote 12 and I wrote 18, and I put the little box, the little upside down L, backwards L. No, I guess that's a forwards L. Yeah, that's a forwards L. I put an L underneath there, and I divided 12 and 18 by 2 to start. So 12 divided by 2 is 6, and 18 divided by 2 is 9. So I wrote those down, and I know those aren't prime numbers, so I had to do another L. And I looked at 6 and 9. 2 doesn't go into 9, so I'll try 3. Yeah. 6 divided by 3 is 2, and 9 divided by 3 is 3. 2 and 3, those are prime numbers. So I just bring it down here. 2 times 3 times 2 times 3 equals 36. So now let's do 16 and 40 using the ladder method. So I have 16 and I have 40. Neither of those are prime numbers, but I know that 2 goes into both of them, so 2. So I'm going to say 16 divided by 2 is what? Or I also could say 2 times what number is 16? Well, 2 times 8 is 16, and 2 times 20 is 40. Those aren't prime numbers. Let's do it one more time. 2 goes into both of those. 8 divided by 2 is 4. 20 divided by 2 is 10. Still not prime numbers, but 2 will go in there again. So 4 divided by 2 is 2. 10 divided by 2 is 5. So now if we just move these down here, right? All of the prime numbers, 2 times 2 times 2 times, another 2 times 5 is equal to 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 5 is 80. So yes, 80 is the least common multiple of 16 and 40.